Okay, this is lesson 4.6, day 2. It's actually solving absolute value inequalities. The proper week I already collected. Edmentum is due, and on Tuesday we're going to have a quiz. Here's the answers to last night's homework, so you can check it. Go ahead and pause. All right. Now, when we are solving any type of absolute value equation inequality, I'm going to write over here to remind us the steps. Number 1, isolate the absolute value. Isolate it. Get it alone. Then, step 2, rewrite to appropriate and or statement. Then solve. Now, what we did, look at you, make sure you're paying attention because you're missing this next week. We already did absolute value equation. If I said the absolute value of x is 2, the way you rewrite that, that's an equation. The equations are easy. X has to be 2 or x has to be negative 2. So I could have done all kinds of work leading up to this to isolate that. I might even have equations here that I still need to solve, but that's how you rewrite it. Now, there are 2 other scenarios. The absolute value of x is less than 2. One thing I'm going to note over here, I'm going to put a little side note. When you're isolating, get the absolute value on the left. You want it set up like this. The absolute value is less than 2. Always have your absolute value on the left. When it's an equation, it does not matter, but it certainly matters here. Now, this is what I was talking about, understanding. I'm going to draw a number line. Here's 0, here's 1, here's 2, negative 1, negative 2, negative 3, and 3. Now, this number line is going to help us understand why we rewrite the absolute value the way we do. Okay? It is less than 2. So, let's start filling in numbers. Make this less than or equal to life will be easy. Start at 2. Is the absolute value of 2 less than or equal to 2? Yes, because 2 is less than or equal to 2. That means I'm going to have a solid circle right there. Now, let's go one way or the other. I'm going to work you on this way. If I put 1 in, the absolute value of 1 is 1. Is 1 less than 2? Yes. If I put 0 in, the absolute value of 0 is 0, that is less than 2. The absolute value of negative 1 is 1. Is that less than 2? Yes. The absolute value of negative 2 is 2. Is that less than or equal to 2? Yes. Keep going. The absolute value of negative 3 is going to be 3. Is 3 less than or equal to 2? No, it is not. The numbers that make this true are right there. Would 3 work? The absolute value of 3 is 3. 3 is not less than 2. So, what does that tell me? That tells me that to solve this, whatever the absolute value is goes in the middle. It is an and statement. You make this number negative, put it down here, all less than up to the positive. That is the rewriting part. Why do we rewrite it that way? Because these are the numbers that are going to make it true. Between negative 2 and 2, that's true. That is an and statement. And then I would solve from there. So when you have an absolute value and a less than a number, it becomes an and statement. down here, all the way up, less than. Now, what's our other option? Absolute value of x is greater than or equal to 2. This is option 3. So look what we have. Equals, less than, greater than. Those are our only options. So again, I'm going to draw a number line. 0, 1, 2, 3, negative 1, negative 2, negative 3. Okay, let's start at 2 again. The absolute value of 2 is 2. Is 2 greater than or equal to 2? Yes, so I have a solid circle there. If this was just greater than or up there just less than, it would be an open circle. Let's go this way. The absolute value of 1 is 1. Is 1 greater than 2? No. Is 0 greater than 2? Is 1 greater than 2? Is the absolute value of negative 2 is 2. Is that greater than or equal to 2? Let's continue to go. Negative 3. The absolute value of negative 3 is 3. Is 3 greater than or equal to 2? What about 4, 5, 6, 7? So I'm going to have a solid circle shaded that way. And let's start working up the other way. What if I put 3 in? The absolute value of 3 is 3. Is 3 greater than 2? 4, 5, 6? What is that graph? When it goes out, it is an OR statement. Now this is what freaks kids out. You need to rewrite it so it means this. So on this side, x is less than or equal to negative 2 because it's going to go out. This part of the graph, x is less than or equal to negative 2, or x is greater than or equal to 2. So as soon as you see a greater than statement, it's going to go out, and you need to rewrite it so it goes out. It'll be less than the negative and greater than the positive. And if you forget that, because literally, I remember learning this when I was in school and thinking, how in the world are you ever going to remember that less than translates to this and greater than translates to that? Well, how do you remember it? You do what I just did. You literally do what I just did. If x is less than or equal to, what numbers are going to make that true? Between those two. That's an and statement. Write it appropriately. Do what I just do here. It goes out. And I will tell you, I have to think about this. Like, I see these all the time. I've been teaching algebra for almost 30 years. And I have to think, less than, which way did that go? Well, less than, or could it would be in between, so that's how you translate it. Greater than would go out, so that's how you translate it. So, let's look at an example. Okay. I'm not even going to do that. I don't like that. Here's how to solve. The absolute value of x minus 3 is greater than or equal to 4. Does greater than go out or in? Greater than goes out, so it is an OR statement. So our first side will be x minus 3. If I want it to go down this way, what am I going to write? If I want it to go down this way, what am I going to write? Is it going to be greater than or less than? Less than or equal to negative 4. Or, sorry, what's wrong? Our top half of our graph is going to be x minus 3 is greater than or equal to positive 4. This is going out. Do you need a pencil? Do you have a pencil? Okay. Now, let's solve this. Add 3. So x is less than or equal to negative 1. Or add 3 is greater than or equal to 7. Here's our graph. Negative, well, why am I writing negative 7? It's not negative 7. Negative 1, less than or equal to, solid circle, going left. 7, solid circle, going right. Those are the values that would make this true. So, let's test it. Give me a number that's in the middle here. 5. Let's put 5 in. 5 minus 3 is 2. Is the absolute value of 2 greater than 4? No, it is not. None of these numbers in here would work. All the numbers to the right of 7 and all the numbers to the left of negative 1 will make that inequality true. Okay. Change this to less than 5. Change that problem to the absolute value of x plus 2 is less than 5. Okay, a less than, is that going to go in for and or out for or? In for and. So, take this number, make it negative 5, and put it down here, because you always go small to large. Less than, x plus 2 goes in the middle, less than 5. That is an and statement. You read that. X plus 2 is greater than negative 5, and x plus 2 is less than 5. That's how you rewrite it. Make this negative, move it down here, and then you have less thans the whole way. That's how you write an and statement. Let's solve this bad boy. Subtract 2 from all 3 spots. So I get negative 7 is less than x, and that's less than 3. So here we go, negative 7 and 3. What kind of circles am I going to have on negative 7 and 3? Open, because we don't have equal to. And where is the shading going to go? Between them. This means that every number that is between negative 7 and 3 will make that inequality true. Let's try one. Give me a number. How about 0? Isn't 0 between these? 0 plus 2 is 2. The absolute value of 2 is 2. That is less than 5. Any number in here will make that true. Any number on the outside of that, it will not be true. Let's try one. Let's try 10. 10 plus 2 is 12. The absolute value of 12 is 12. 12 is not less than 5. So it would not be a solution. Okay. These get a little more tricky. What do I need to do first to solve this absolute value? Yes, remember, you need to isolate. You need to isolate. So, divide both sides by 3. So I'm going to have the absolute value of x plus 4 is greater than 5. All right. That is a greater than statement. Does greater than go out for or in for and? Out for or. Okay, so if it's going out for or, x plus 4 is going to be less than negative 5. That's going to give me my bottom half. Or x plus 4 is greater than 5. That's going to give me my top half. It is going to go out. Subtract 4 from both sides. So x is less than negative 9, or subtract 4, x is greater than 1. So here's negative 9, open circle, shaded left, and 1, open circle, shaded right. If you want to test, take a number that's in between these, 0. If I put 0 in here, 0 plus 4 is 4. The absolute value of 4 is 4. Times 3 is 12. Is 12 greater than 15? No. And that's not shaded. So I'm probably right. Let's try a number that's down here, 10. 10 plus 4 is 14. 14 times 3 is definitely bigger than 15. That's shaded. I can try something down here. Let's try negative 10. Negative 10 plus 4 is negative 6. The absolute value of negative 6 is 6. 6 times 3 is 18. That is greater than 15.